Vitally important that you never ever write that limit equals 0 over 0 or that it equals the infinity over infinity, because neither are numeric values and thus cannot be equated to any other expression. So that's why I was having you yesterday write out the two separate statements. So let's go ahead and, like, honestly, what I do is I mentally do the plug-in. Okay, so I can already tell the denominator would be 0. If I plugged in it in the numerator, that would be 1 minus 1, which is 0 over 0. So unfortunately, I've got to write it out, okay? So I know that's a bummer, but we're going to have to do that. So let's do my desktop is like my brain. It's like I've got 50 things there. Oh my God, seriously, my brain is pretty bad. And as I get older, the worse it gets. Okay, so here we go. The limit as x approaches 0 of cosine x minus 1. I know that's going to be 0. The limit as x approaches 0 of x squared minus x is 0. So L'Hopital's rule applies. And as long as you state that, you're golden. So go ahead now and apply L'Hopital's, where you're going to find the derivative of the numerator, the derivative of the denominator. I'd recommend doing a quick mental check. And then see if you can, in fact, evaluate the limit. All right, so it is okay to do this. So that's what? Negative sine x over 2x minus 1. Ooh, that's going to be just fine then, because I would get negative sine of 0 over 2 times 0 minus 1. It is okay to get a limit to equal 0, and that one works. Questions on letter A? All right, I'm going to pause, and I want you to try letter B. So L'Hopital's rule applies. So then I'm going to go ahead and do the derivative and get 1 over x minus 1 over e to the x minus e. Now, do you get that? When it's e times x, the derivative is e, right? That e is that coefficient. So now I'm getting, if I plug in 1, that's going to give me That's 0. And if I do e to the x minus e, that's e minus e, which is 0. So L'Hopital's rule applies again. So let's do the derivative. So this is x to the negative 1, so that'll be negative 1 over x squared over e to the x. Ah, there we go. So that's 1 over 1 over e to the 1. So that's negative 1 over e. So we did talk about that yesterday, that sometimes you have to do a repeated L'Hopital's rule. In letter C, we actually don't have to do L'Hopital's on this one because the limit as x approaches infinity, this is our horizontal asymptote, isn't it? When you have polynomial functions over polynomial functions, you know, to create this rational function, then what I did this one on purpose to show you that this really is just representing the horizontal asymptote, and so it's just negative 5/3. This one would be a multiple choice question, okay, so no work really required on that. Let's try letter D then. Now, of course, you can do L'Hopital's, you know, and L'Hopital's is more often a multiple choice question. So, I hate to make you do this, but if it is on a free response, and they have been since 2017 incorporating that, so I want to make sure that we get the whole point for that. All right, so try letter D. Try this one the whole way on your own. I'm going to return the latest quiz today. They're not in the folders yet, but I will return. Okay, so on this one, when I do the limit, this one's a little different because my limit is x approaches infinity. So that's going to go to infinity. The limit as x approaches infinity of that denominator. So remember, in e to the 5x looks like this. So it's going to shoot to infinity. So L'Hopital's rule applies. So then this would be equivalent to 8x minus 5 over 5e to the 5x plus 1 over x. Well, I'm going to have a problem again because the limit as x approaches infinity of 8x minus 5 is going to infinity. And that's going to go to infinity. So we've got to do the derivatives again. So that's 8 over, 25e to the 5x This will be minus 1 over x squared. Now when I plug in, I'm going to get 8 over infinity. And when you take 8 divided by a number that's increasing without bound, that's going to 0. So something I want, yeah, Michael? We probably ought to, yes. So watch, I'm going to lasso that one. And I bet you guys have already been doing it, huh? Duplicate it. There we go. All right, let's look at example 3. Now these are similar problems that you might see on a quiz, a test, the AP exam. So it says find each of the following limits. I'm going to give you a few minutes head start, and I want you to try A and B. See what you see. Well, what is the limit as x approaches 3 of f of x? 0. And then my limit as x approaches 3 of x squared minus 9, that's 0. So L'Hopital's rule applies. So I could say this is the limit as x approaches 3. Watch this. F prime of x over 2x. Well, what is the derivative? This is so cool. It's like really neato. Is if I want the derivative at 3, do you see this is a line segment? So I know how to find the derivative of a line segment on a graph. So what is that slope? Negative 2. Good job. That's negative 2 over 2 times 3, and that would reduce to negative 1/3. All right, try B. All right, on this one, I'm going to go ahead and do the derivative of my numerator. So f of 2, that's 4 minus 4 is 0. Then I have the denominator, g of x times x squared. G of 2 is 0. So L'Hopital's rule applies. So this is equivalent to f prime of x. Then you've got to do your product rule. So this is going to go first times the derivative of the second plus the second times the derivative of the first. So I'm going to plug in. That would be f prime of 2 over g of 2 times 2 plus 2 squared times g prime of 2. So that's going to be negative 1/6 when you're all done with that. All right, questions on number 3, A or B? All right, then example 4. This is from the 2018 free response section, question 5, letter D. So it says, let f be a function defined by f of x equals e to the x cosine x. Let g be a differentiable function such that g of pi over 2 equals 0. This is really important. G is a differentiable function. The graph of g prime, the derivative of g, is shown below. Find the value of the limit as x approaches pi over 2 of f of x over g of x, or state that it doesn't exist. Justify your answer. So let's take a look here. And if I do just the numerator, f of x is e to the x cosine x, so that's 0. The limit as x approaches pi over 2 of g of x. Okay, this is really, really important. This is what they love to do to you on the AP exam. What is this the graph of? It's g prime. It's the derivative. This is not g. But they gave me some information somewhere else that if it's differentiable, what does that imply? It's continuous, right? If it's continuous, what do you know? The limit and the function are defined at the same value. So what is the limit as x approaches pi over 2 of g of x? It's 0. All right, so that's why I highlighted that. That is like so important. And you might just like gloss over that, and we need to stop. We need to stop doing that. When g is differentiable, it means it's continuous. That also implies that the limits equal that defined value. Those are all things that we now know. So, L'Hopital's rule applies. So, let's try f prime of x over g prime of x. All right, well, f prime of x, that's the first times the derivative of the second plus the second times the derivative of the first. And I'm going to leave g prime of x because we're going to go get it on the graph. So this is e to the pi over 2 times negative sine pi over 2 plus cosine pi over 2 times e to the pi over 2. What is g prime of pi over 2? 2, right? G prime, this is the graph of g prime, so it's very tempting. Students want to say undefined. Then you're talking about the derivative of the derivative. The second derivative is undefined. But my first derivative at pi over 2 is just a number. So let's keep all that straight. So this is going to give me negative e to the pi over 2, because that's 0, right? That's my final answer. So that was one part of a free response question. So do you see all that? And so they did put a L'Hopital's rule on the free response. All right.